Welcome to the PrairieLand Advantage. We're talking about 50 through S700 series STS combines today, and this is broken down into several sections. Today's topic is about crop flow and adjustments of only the feeder house. So we are excited to bring you this information that will hopefully help you optimize your John Deere STS combines. One of the things we've done to try to help you, if you just want to know about the feed accelerator, you're going to see that that would be at the last of our presentation because we like starting at the front of the machine and going to the back, just like the crop does. And you're going to see that in our training, we teach folks to start at the front and work to the back, and that's how we'll explain it today. Thank you for joining us. My name is Drew Lowry.
And I'm Dave Thiessen.
And our job today is to help you understand these STS combines. And as you can see on the picture in front of you, we're talking about the feeder house. Now, it has two very important jobs. And one, of course, is to carry the header around, but its job is to compress the material to where we can get it from that header into the actual STS rotor that we're going to be talking about in the next section. So the feeder house has very important jobs. And the good news is it doesn't have a whole lot of adjustments. And so we're going to be able to cover this topic and help you get the maximum throughput from your John Deere STS combines.
As we look at the feeder houses on any type of machine, one of the critical things to think about and talk about is the handoff of the header to the feeder house and making sure that we have our crop mat evenly laid out in front of the feeder house, because what happens at the header and hands off to the feeder house affects machine capacity of the feeder house and also the rest of the machine. Previous to this, if you've looked at our other videos on the auger type headers, 900 series and 600 series headers, we've talked about handing off and making sure the auger strippers are set correctly so we feed it out evenly in front of the feeder house so we deliver the crop to the machine in the right pattern.
Now, the first topic we're going to talk about is the orientation of the header to the actual feeder house. Now, if you've got a 50 series combine, and let's say you have a corn head situation, you need that corn head angle to be a little flatter. On a 50 series combine and combines preceding that, you're going to need what is called a corn head wedge kit. Here's one vendor that supplies that with us from Lankota, and that fits between the actual header as well as the feeder house and helps adjust that angle to a more optimum setting. Now, if you have a 60 series to S700 series combines, you have a front feeder house plate angle adjustment. So how does that work? Well, if you need to make that adjustment, you would loosen all the bolts in the red circles here. You then utilize the turnbuckles in the blue circles, and those turnbuckles are only meant to adjust it as I am repositioning it. Now, where should I put it? Well, that's what this chart is helping us. A really good starting place is that 34 inches from the ground to the pivot bolt dimension, and with the front feed plate being perpendicular to the ground, is a really good starting place. Now, that doesn't mean you have to stay there. Maybe you need it nose over or nose high, but that is a really good starting place that works in many, many conditions. Now, one of the things we need to review with everybody is that the bolts I'm pointing out here are bolts that need to be torqued to 235 foot-pounds. This bolt here on the bottom needs to be torqued to 460 foot-pounds. So the point is that the hardware on this adjustable front feeder plate is what actually carries the feeder house, and to the header, it makes that connection. Because after you torque those bolts, you should go back and take the pressure off of these turnbuckles, because it's not their job to carry the header around on this feeder house. Now, if you have an S600 or S700 series combine and you ordered the hydraulic 4.5 feeder house tilt kit, that's factory only, you will get from the cab with a button 17 degrees of feeder house tilt. Now you can see that's quite a bit of change in angle, and that's going to help you get underneath that down corn or keep that cutter bar out of the dirt and give you better, longer sickle life. Let's now start talking about attaching the header to the feeder house. What you see here is how we will do it on a multi-point header connection system on a 50 series combine. So looking at the left-hand side of the header here, you're going to see 2 hoses and 1 electrical connector that's going to hook to the feeder house. As we look on the right-hand side here, you're going to see 3 hoses that need to be connected to the header from the feeder house. Now, the good news is when it's time to road to the next field, you've taken the header off, there's storage brackets and hooks on the right-hand side and the left-hand side to keep those hoses out of harm's way and where you're ready to reconnect at the next field. Now, if your combine is a 60 through an S700 series combines, those models are equipped with a single point hookup. I'm circling that here with my pointer, and that single point hookup is a very reliable system, but we need to do a little maintenance on it. We need to take care of that. So we would recommend only cleaning that with John Deere TY 26632 electrical contact cleaner. Why? Well, it's an oily surface sometimes, and dirt attracts to it, but that contact cleaner will not harm the plastic or the rubber components, whereas if you use brake cleaner, like a lot of you have, that could harm this and cause leaks sometime in the future. So how does this work? The single point attaching that is stored on the header has an over center latch. I take that loose, and I then insert that in the combine single point, and then I take the handle from the vertical position shown in the right-hand corner to the horizontal position shown in the left-hand corner, and I have locked that in and down. Now, Dave, what have you seen as far as things I need to make sure that this single point hookup has been working?
Well, I've seen in the past where we've maybe haven't got the feeder house latch pins fully engaged into the feeder house brackets, and one pin or another maybe hasn't fully engaged, and we need to every once in a while we do that and make sure the linkage is all free and the pins are properly adjusted, and that we are engaging fully into the latch points on the header side so that we know the header is fully latched and secure to that feeder house and not compromising a situation that could be harmful or safety-wise dangerous.
So don't I remember right, Dave? We need 4 corners, all 4 corners of this header to feeder house attached, and that's what our over center single point hookup does for us, doesn't it?
Yes, it does. And it also has on that single point connector there that you were mentioning, has a shear pin on the later ones, and that shear pin can shear, and then it comes over just fine when we latch the single point hydraulics and the electrical connector, but sometimes the pins won't engage fully out into the header and latch. And that is something that we want you to be aware of and be concerned to pay attention to that.
Very good. So as you're hooking that drive shaft up on the left-hand side, look at those pins. But even if you don't have a drive shaft on the right-hand side, we would highly recommend you look at the right-hand side of the feeder house too, as Dave just recommended. Some nice features on those 60 series and newer combines. Let's then move into our next topic, and that is about the driving system. So we're going to have a quick discussion about our gear cases. Shown here on the left is the heavy-duty reverser gear case that's belt-driven. Shown on the right is the high-torque version of that. So depending on which model you have and how it was ordered is what you're going to be experiencing. Now, please note that these are variable speed units. So what they are is they are a system that has to adjust its spacing. Let's talk about keeping these systems working well. That is going to be done with appropriate greasing. So the greasing process of these variable sheaves is, number one, read along with me, run the sheave to its highest speed. So make sure the sheaves are as wide apart as they can be. Then manually position the variable sheaves as shown with one grease cert at 12 o'clock and another grease cert at 2 o'clock. Yes, go ahead, Dave.
So when we want to run that feeder house variable speed up in speed to make the belt draw down in that sheave set, so we do the greasing like we're talking about here, on a 50 series machine, we will have to, or even a 9600 previous Walker machines, we have to take the real lift hydraulics and plug them back in on the left side of the feeder house into the female Pioneer plug-in so we can get the variable speed upper set of shivs to do the work and the action for us. On a 60 series with that single point hydraulic hookup that we just talked about, if we don't have a header hooked up to it internally in that single point block, there is a bypass orifice, and it allows the variable speed to work up and down on its own without the header hooked up. So in short, if you have to run up and down your speed on your variable speed feeder house, which Drew's going to talk about here in a little bit on how after we've greased it down there at key point number 7, then we will want to unhook our single point adapter off a 60 series and then go to our hydrostat handle and run the real lift control up and down to work with getting our variable speed in position that we want it to be.
Very good, Dave. Thanks for that reminder. The purpose of what we're trying to accomplish here is make sure we're getting grease in the right quantity and the right places. Now, point number 3 is that there are only 2 greases that we suggest, and they are TY6341 and TY25744 greases. Now, why are we so specific about that? Well, those are the greases recommended by the John Deere Manufacturing, and what we've seen in field trials is these 2 greases do not dry out and therefore allow components internally to get damaged. Point number 4 is if you're in high yielding crops, such as like 200 bushel the acre crop, we need to grease this at least once a day, no matter how many hours you're putting on it. But the book says we need to grease the 2 o'clock zert 3 to 5 pumps every 10 hours of operation. Now, that 2 o'clock zert in the picture here is providing grease to the inner cam surface and the grease seal itself. So those 3 to 5 pumps per 10-hour day are going to keep that working well. Now, the grease zert pointing straight up takes a few more pumps, 8 to 13 pumps every 10 hours, but this provides grease to the cam's cavity. So that's a bigger area, so it takes more grease. Now, one of the things that's easy to forget is that even if you have to move the hose around, as Dave described, is we need to cycle this system a couple times, minimum to maximum, so that we get that grease all spread around and doing its job throughout the whole system. So this is the simple thing, but we sometimes get in a hurry and forget to do this simple greasing process. The next thing, as Dave said correctly, is that we need to make sure that our shiv gap is correct. And the shiv gap we're talking about is right in here where I put my arrow. And we need to make sure that that is no closer than an 1/8 inch. Either way, it can't be tighter, can't be looser than that, either more than a 1/16 of an inch from that 1/8 inch. So how does this work? Well, what happens is at the upper end of that belt is the shiv on your lower right screen here. So this shiv has built into it a hydraulic cylinder. So that hydraulic cylinder is pulling that belt rearward, and the shiv reacts against that spring. And if this gap is wrong, what happens is the cylinder is strong enough to hurt the belt, and that is not a good thing. So if there's more than a 20 RPM difference in either the high or low speed that it should be, depending on what model you have right here shown, you need to understand your readjustment process. So we're going to now run the variable shiv to slow speed, stop the machine and measure the shiv gap. It must be a 1/16 either side of 1/8 of an inch. If it's any more than that, it's time to readjust. How do we do that? What we need to do is make sure that we use move the upper unit to where the lower unit has that correct gap. Dave, what bolts do we utilize to do that?
So you see there on the picture, and it's very easily mistaken, is there's 3 bolts on the outside by that push bolt right there. Well, those 3 bolts, if you look at how that's built, that is set up to align the shivs so we keep the shivs aligned with the belt so the tracking and the power can be applied to run our higher demands on our bigger headers and larger corn heads. The actual bolts to adjust the shiv gap are the bolts that hold the whole shiv unit on the inside up against the feeder house casting. And you'll have to look in between the brackets behind the one that's there with that arrow pointing to it. And we'll look at the ones that are actually holding it to the casting, because we're going to take that whole upper shiv unit and push it up or pull it down. Pushing it up will make the shiv gap larger, and pulling it down will make it less of a shiv gap. And while we're making these adjustments, we have to remember that either we want to hand turn the belt so things can relax and find that new shiv gap spacing that we just adjusted for, so we can check that, make sure that we're either not too wide or too narrow, or we can sometimes make sure any bystanders are out of the way and fire up the machine and run the feeder house just for a short bit to let that shiv gap find its new set before we consider it adjusted correctly.
That's right, Dave, because that spring doesn't have enough power to change the shiv gap until it's moving, does it?
Exactly. It's a posi-torque drive system that requires the motion of the belt turning to sense the appropriate torque on the belt.
That's right. We've had that feature for a long time, and it saves the life of our belts and makes them live longer because they're only tight when they need to be. Let's move to that front unit here on two different types of feeder house drives. The one on the left isn't found around here very much. It's called the fixed speed feeder house. But we like this picture because it shows us how to check the oil level here in our dipstick. First of all, we need to have the feeder house safety stop down in its stopped or supported safety position, and then having the feeder house down against the cylinder. At that point is when we do check the oil. Now, Dave, how does that change a little bit differently when we have a reverser with a cooler on it like this one is?
Well, due to the oil cooler reverser being part of the makeup oil or the reservoir for the reverser, and the pump that's in the reverser pumping oil to that cooler and bringing it back as fresh, cool oil, we have to engage the feeder house and run the feeder house just for a moment while it's sitting on the header safety stop, as you previously mentioned. And then we will park and shut the engine off, pull the dipstick out, wipe it clean, thread it back in, and check that oil level with it sitting on the threads to verify that our oil level is correct. That way the oil cooler and the reverser have their pre-charge of oil before we check the oil level.
Dave, in your experience, do you have a preference on type of oil we would put in that reverser gear case?
As the 70 series came out from the factory, they have an HD 460 heavy duty synthetic oil that is a high quality oil, and I recommend using that. The other oil that is another synthetic, and why we use synthetics in our gear cases on our machines are the synthetics, when they are in a real hard pulling environment, they don't oxidize and they don't become burnt like 80-90 weight can. And also when you're in storage with a machine in the off season of harvest, the synthetics leave behind a residue that keeps the gears from rusting in this humidity that we often have. And that's a critical and important to making sure the life of the reverser and even the primary countershaft gear case behind the cab drives are used for a lot of high horsepower load, and those then the seals and the gear cases last and live a lot longer.
Yeah, we were talking earlier that some of the horsepowers that are required for these larger corn heads could be pushing 200 horsepower. So that's really a system that we need to take care of because of all this load, isn't it?
Yes, sir. Yeah, it is. It's really put a challenge with some of the processing we do through corn heads on these reverser feeder house drives. All
right, thank you very much. Let's talk about our feeder house drive system that has the biggest load carrying capability, and that is called our multi-speed or 5-speed feeder house is what we all call it. We like this because number one, it has it's got our highest load carrying capability, but we also like it because of its speed bands. You can see that we have between around 10 to 12% speed change in each one of the different gears. What that allows us to do is match our snapping roll speed to our ground speed so that we are processing those corn stalks appropriately. So the 5-speed feeder house has been a nice addition to our product lineup. Another reason everybody likes it, we call it the power shift transmission on the combine. We call it that because the clutch discs, as you see here on the right-hand picture, these clutch discs here would be very similar to the clutch discs found on John Deere farm tractors, and we know how reliable those transmissions are. Now, you may wonder, where am I looking right here? That is behind the cab, underneath the grain tank, and that is our 5-speed feeder house, getting its power right from the engine gear case and that drive shaft you see that I'm pointing at right now. Now, as we get to the bottom shaft of the feeder house, that is what's being driven by the gear case there. So Dave, what thoughts do you have about this area?
Well, I'd like to back up just a little bit, Drew. While we're in the feeder house drive area, talking about that, let's make sure that the customer understands that they need to, for knife drive type headers, it doesn't matter if it's this 5-speed or the variable speed feeder house drive with the belt system, that they have slowed this all the way back down to the slow gears for before we hang on grain type small grain headers with sickle drives. If we have a knife drive, we have to run it in the slowest speed, as Drew referenced there earlier, that 480 on the 50 series, maybe 520 on the 60 and 70 and the newer machines. We have to make sure we're down to that slower drive system, because today's feeder houses are made for higher RPMs and can run higher. But if we don't slow them down all the way, our knife drives are not capable of holding together with that highest sickle speed and that high drive speed.
Dave, I know they're supposed to do that automatically, but that's good advice to make sure that that actually does happen. So what we're talking about is the speed of this shaft right here. So what this shaft does for us on the right-hand side of the feeder house, you can see our speed sensor right there, is we now are controlling the speed of the feeder house chain, particularly on your small grain crops. So Dave, what are we recommending at PrairieLand about the different sprockets here in this area for different crops?
Well, as you can see there on the example, 22.2 sprocket, that is a smaller sprocket for corn. It works well to prevent kernel damage and ear damage as we bring the crop out of the header into and prepare it for threshing in the handoff from the feeder house to the feed accelerator. And then the 26 tooth is for wheat and beans, and 38 tooth is a larger sprocket. And that sprocket is available, and it's through service or parts department, and it's a larger sprocket for high yielding, big windrow type crops. Most of the time in our small grain situations here in Kansas and our central United States, we will put it basically on the 26 tooth sprocket and run it through most crops. If we do think we have a limiting factor in capacity from the feeder house, we can go ahead and put it on the larger sprocket. But when we run it on the larger sprocket, as you'd mentioned earlier, Drew, we are running our feeder house conveyor chain with the slats faster, and we have seen that reduce the chain life and the costs of upkeep of the feeder house, and we can still run a good capacity and keep up with the machine capacity on that 26 tooth sprocket in most conditions.
Very good. And one of the things you got to get your mind around is the driving sprocket is the front one. The driven sprocket that we don't ever change is the rear one. But Dave, what have we seen relevant to the radial pin slip clutches, and how can we make those live a good, long, normal life?
Yeah, many times the radial pin slip clutches get overlooked for being greased. You know, it used to be if we put applied grease to a slip jaw type clutch, that caused that clutch to cause us frustrations because it wouldn't hold its torque and its load, and it would slip prematurely. With a radial pin type slip clutch and the plungers and the springs that are in there, we need to make sure that it's been kept with some fresh grease applied to it, so those pins and those plungers can move freely. So if it needs to slip, it can slip at the appropriate torque, but then at the same time, when it stops slipping and needs to hold, if we don't have the fresh grease in there, those pins and plungers can't hold that load. And then, so we need to keep fresh grease in those radial pin slip clutches.
Very good. And that's easy to do. There's either one or two zerts there not shown here in this picture, but don't overgrease, but certainly don't undergrease, as Dave just recommended. Following that chain into the upper drive shaft of the feeder house chain, what we're seeing now is the front of the feeder house. So the feeder house chain is what we're talking about as far as crop throughput. So the speed of that chain does control our throughput, but also the opening does. And so you can see that as we went from 50 to 60 series feeder house widths here, that we have a larger opening here in our 60 series feeder house. Now, once in a while in those 60 series feeder house, we might get some crop buildup here on the drum between its two stops. And how we fix that is on our 60 series combines, we put a 70 series kit on them that will lessen the amount of crop buildup in these areas. Now, there's some things we've got to do to the arms as one less chain link, because this bubble was designed for a 70 series. We got to modify it just a little bit, but you can see that could be really handy. Now, tension on all changes is important. Let's talk about the feeder house chain right now. On the 50 and 60 series combines, you're going to see a eye bolt here. That eye bolt is pushing ahead a drum that we just showed you in the previous picture. And the correct tension for that is found by looking through the top of the feeder house. Dave, what are we looking at right here?
So many times it's mistaken on how to keep that chain adjusted properly. And so you can see the gentleman reaching in the feeder house top door, and in the middle of that door is where we want that upper chain to touch the intermediate floor, not by squeezing it, but it should just naturally want to rest there at point F, as you can see they're being pointed at. And so we adjust the chain to either just to touch at the point F there and not be too tight. If it was tighter, it would be farther up to the right, to the back of the feeder house. And if it was too loose, it would be closer to E and it would be hanging down. And so that maintains a proper chain tension. So as we bring in the crop and the drum floats up and floats down, we're holding that crop, engaging that crop solid and grasping it and pulling it and pushing it towards the feed accelerator on the STS machines.
All right, very good. So that chain tension is important. And this next graphic will show us why it is so important. So what we're going to do is we're going to start this video running, and we are going to be able to see what Dave was just explaining. So as this feeder house turns sideways, what we need to do is we need to understand that this chain would actually be a little bit too tight, wouldn't it, Dave? But this is just a video drawing trying to show what we're talking about.
Exactly. The tighter the chain, or too much chain tension, actually wants to hold the drum up off the crop and makes that dead space between an auger type header and the feeder house chain lower slats a wider space, sometimes delaying that crop flow, sometimes creating a slug feeding in damper, tougher conditions.
So on Walker combines, 50 and 60 series, this would be the style of feeder house chain that we have. So when the 70 series came out, what we have is we put those feeder house bubbles on that we talked about that would retrofit to our 60 series. Now, as we explained earlier, the purpose for those bubbles is to lessen the amount of crop that gets back in there and supports the feeder house arm. So Dave, what we did is that when what serial number was it that we introduced this new high performance feeder house?
At 730,000. 2008 is when the 70 series STSs were introduced. In 2010, we came up with a increased capacity and the floating mid-frame drum with a 4x4 type feeder house.
And that's a good catch. So if you've got a 70 series combine, you need to make sure your parts people know which serial number you have, and so you know which feeder house you have. So let's talk about those late 70 series and the S600s and S700s. What we did in that feeder house is we increased our capacity by 15%. And we're going to show you in a second, the drum and mid-frame are now one solid piece that are shoved forward and backwards to tension the chain. So let's look at the late 70 series. The late 70 series had three chains on their drum, and they had the cast iron slats. What's different about those cast iron slats, I'm going to point at them here, is that they rode on plastic isolators. And so the chain wasn't responsible anymore for supporting the slat. They were supported on the top and not shown here on the bottom by these wear strips. So what that does is it helps that feeder house chain slat to stay in better contact with the crop as it's feeding. Let's turn to this picture. When we then came out with the model year 16, we went from the 3 to the 4 chain and went from 2 different slats to 3 different slats on the feeder house chain. And if you think of the crop flow that is trapped underneath this chain, this 4-chain model probably works better than the 3-chain model because all feeder houses tend to have a little bit more crop in the middle. So that's why we've gone to the 4th chain on these later feeder houses. Now, this video here that I'm going to play is showing the full floating frame. And the pivot I want to point at here is right where my pointer is here. So as I start the video there, what you're able to see is that the pivoting point of the whole section is, it stays together. And the other thing that you hopefully can see in that video is the chain on the bottom is supported by wear strips there, and that's what helps keep those oriented correctly so that they are doing the best job possible of transferring power. What we need to talk about now is tensioning the feeder house chain. Dave taught us earlier that on the earlier headers, we needed to make sure that we had some looseness on the top part. That isn't the case on these new machines, is it, Dave? What have we seen over the years relevant to this tensioning spring and this measuring tool right here?
Yeah, so in 2010, when the new feeder house 4x4 larger, higher capacity feeder house was introduced, we also introduced the spring-loaded feeder house conveyor chain tensioning that you're seeing there where the cursor is pointing down in that lower white circle. With that, spring tension early on was sufficient, but as we increased capacity and got into some tougher, damper crops, we found that sometimes the feeder house conveyor chain wanted to slip. And what we found was the tension was maybe not sufficient for the job and the load it was pulling. So later they came up with, and there is a new tension gauge that is part of where the cursor is pointing, and the spring. The spring is the same, but the spacer pipe in the spring and the gauge are shorter to allow a tighter feeder house conveyor chain to keep it from jumping the upper sprockets. I know that's been some frustration for some individuals and customers, especially it seems like in soybeans when we have a tougher feeding situation. Sometimes it can happen in wheat when we're in a real tough situation, and that load causes that spring to release the tension on the feeder house chain. So there are some fixes for that. Just check with your parts department and get a shorter gauge and a shorter spacer pipe and original spring. If you've got a feeder house that's got years and hours of use, that spring could be getting to the point where it's starting to lose some of its abilities, and we want to maybe replace that spring to increase the holding tension on that feeder house conveyor chain also.
And one of the things to help make sense of everything Dave just said is we are trying to pull that eye bolt forward in this orientation to tension the chain. And so you gotta think backwards, and our objective is to keep that feeder house chain tight without any looseness, like we said on the previous designs.
Yes, also I'd like to add at this point, keeping an eye on that eye bolt and how it's in the slot where it's on its position. As the chain wears, it's going to move towards the front of the slot, and we've got to keep it in the slot so it doesn't lose the ability to have a place for tension to move itself and keep itself self-tensioned. With that said, how do we get it farther back in the slot is by removing half links, but we don't want to remove half links too early in the life of the chain, because we also want to keep it moving towards the header and keep it as close to the header as we can to prevent dead spots between the handoff from the header to the feeder house chain. And also, if we don't have it fully forward in that slot before we remove a half link, we might not have enough back adjustment in the slot, and we take out a half link and we might not be able to get our chain back together because we don't have enough travel that we accounted for with the wear.
All right, thank you, Dave. And I knew they made a change in that later on as far as its tightness and the bolts that support it. So check with your PrairieLand parts people, and they can help you through that whole evolution. So in model year 18, John Deere did some experimenting in the last half of model year 17, and we found out that the smooth part of the feeder house slat, if it was oriented forward, we had better quality grain samples. What we've also found is that as we got into hard to process soybeans, it still fed okay. Now, let's say that didn't, you could turn the feeder house chain around to where the serrations came first. But in our experiences, we've had really good luck with just leaving it in the flat side first, because it improves our grain quality, our corn grain quality. So hopefully that is something you'll see. Now, if your combine has the cast iron slats and you would like to improve your grain quality, we've seen positive results of turning your previous model chains around and feeding the smooth side first. Now, let's talk about the feeding. One of the crucial things of feeding is having the correct clearance here between the feeder house chain slat and the bottom of the feeder house. Too low and we wear into the metal, too high, we don't feed well. So if we are dealing with grain and other crops, our 50 series combine, we're going to adjust the eccentric letter E here so that we have an 1/8 inch clearance here between the feeder house chain slat and the bottom of the feeder house. Now, when we go to corn, we just flip this cast piece over, and what we're able to do is have 1 inch and 1/8 clearance, plenty of room to let that ear feed in easily. Now, on 60 series, our eccentric is not above, it's behind our feeder house handle, and what we're able to do is just pull this quick latch pin, flip this handle 90 degrees, and we're there looking for a 1/4 inch gap underneath the 60 series corn feeder house chain there. Now 70 series is a similar position, but we're still looking for the 1/4 inch gap, and the handle is very similar to what we saw on the 60 series, and this carried on in to the 4x4 feeder house. Now, we are going to also announce that the hydraulic 4.5 feeder house tilt, because of the cylinders shown here, we didn't have room for the handle, but what we do is have a mechanism here. Here's our little pin, and we're able to adjust our eccentric down to that correct setting of that 1/4 inch gap here. So if you have the feeder houses that don't have the hydraulic 4.5 tilt, you will get the handle as you saw in the previous picture. Now, one of the things we want to understand, and I'll play this a couple times, this is a durability test at our factory that proves that the cast iron straps on the feeder house chain are really tough, because that thing was moving full speed ahead and they slammed that object into it. Hopefully that'll never happen to you. Let's now talk about the handoff between the feeder house chain shown here and the feed accelerator. As you can see, I've drawn a yellow crop flow mat here, and the job of the feed accelerator and stone trap is to do two things. Number one, it's to deliver crop into the rotor section. The last half of the title, though, is stone trap. So what is designed to happen here is that if there was a stone here in my crop material, which happens a lot for the north here, but it could happen even here in the central US, the stone is hit by these feed accelerator and is embedded in the stone trap. Now, one of the things we're going to recommend is that we clean out that stone trap daily. Now let's talk about crop flow from the handoff between the feed accelerator and to the tri-stream feed section from the feeder house chain. Let's watch this video. All right, now as this plays, what I want you to understand is it's talking about 270-degree feeding. Well, how does it do that? Well, what happens is that as that crop is feeding into the tri-stream feed section, we're feeding from here actually clear up to here. And that's where they get that 270-degree feeding. And what that does for us is it gives us good even feeding into the threshing area that we'll cover in our next video that we'd like to invite you to attend also. So let's look at our corn and grain configured feed accelerator here. As you can see, there are 30 different serrated wear plates that come from the factory. And what that job is to do is to propel the crop up into the tri-stream feed section. The stone trap is shown right here. I'm pointing at it, and that's where we would deflect the stones had we have any. Now, one of the things we need to understand is this left-hand floor liner is a beefy piece of steel. And what has to happen, the reason we need that reinforcement there is the crop that we're feeding up here on the right to get that last 90 degrees of feed input there is going to be pushing upwards a little bit and practically sending the crop vertical. We'll cover that in the next threshing section. Let's look at the 30 different feed accelerator wear strips that we can have. If you're harvesting wheat, the preferred wear strip is this one shown here on the right. That is got nice square corners, has good feeding characteristics. If you're doing multiple crops like corn and other things, in model year 18, they designed a wear strip with a rounded edge. And what that's going to have is less grain issues on crops like corn, which are a possible grain damage issue. Now, if grain quality is even more important, we have a swept back wear plate. And this swept back angle actually works well in crops such as edible beans, as also corn. And this is the third least aggressive. And the nicest wear plate of all of them is this one without the serrations, the smooth wear plate. So you can adjust the aggressiveness of your feed accelerator not only by the wear plates, but we can also change speeds. All right, so please understand the purpose of the feed accelerator is to take the grain from the feeder house chain and propel it into the threshing section. So you have two choices on a base machine, 430 or 780 RPM. To make that adjustment, you simply remove the tension with the tensional handle here. You then have a rabbit and turtle indicator, and you can choose between 430 and 780.
When we are wanting to bale straw behind a machine, we have a situation of pre-threshing that happens at the feed accelerator that starts to tear straw apart. And if we were to put the feeder house chain on the large sprocket, the 38-tooth sprocket, and put the feed accelerator on the slow speed, 430 RPM, we're going to have less straw damage as we hand that crop off from the feeder house to the feed accelerator. It can cost some threshing capacity, but if you're wanting to bale straw behind the machine, this is one area where we tear up a lot of straw and make it harder to windrow and bale for cattle feed.
Now we have optional configurations where we can slow it down to 320 to 770, or we can have a high moisture corn kit, which is called the slow speed for 320 to 770. Now, please comprehend that this is different between the model year 16 and 15 age combines. Please comprehend that this, with edible beans, food corn, or any type you have, any crop that has optimum grain quality is desired, this would be an ideal thing to add to your STS combine. Now, we mentioned stone trap earlier. If you see a 50 series combine, its stone trap looks like this area here. But I would invite you that if you have stones in your area, you may want to consider the field installed expanded stone trap for the 50, 60, and 70 series combines. Now, this is the stone trap that is on the S600 and 700, so it has significant more capacity. Now, all of them need to be cleaned out daily. And why is that? Well, because if you have a very dense crop mat in here because you haven't cleaned it out for a week, those stones which are being knocked into there by the feed accelerator might not be able to do that. And so we need to clean this out daily. Even if we don't have stones in our field, we need to assume we might have stones. So we hope that this has been a good review of the crop flow and adjustments you need to do on your John Deere STS feeder house. These last two slides here are to give you some ideas of things that have evolved throughout the years, from 60 series all the way up to the 2020 model year machines. With that, we're going to invite you back to the other sections of our STS crop flow and remind you that PrairieLand Partners, our job is to deliver you the right solutions for your harvesting processes.